Hi guys, today we're gonna do this is gonna be a chapter 3 practice test part 1. So I'm gonna do this in different parts because I know this is I'm trying to make these videos like an hour or less. So this is chapter 3. This is what a typical chapter 3 practice exam might look like. So in this so this is part 1 of chapter 3 practice test. In this practice exam, I will go over vertex, standard form of quadratic function, discriminant rule, x-symmetry, y-intercept, concavity, polynomials, graphing polynomials, and behavior, x-intercepts, multiplicity, and just all the steps of graphing a polynomial. So let's begin. So question in exercise 1 through 2 says sketch the graph of the quadratic function without using a graphing utility, identify the vertex and the x-intercept. So on question number 1, we got to find the vertex, we got to graph it, and then we got to find the x-intercept. So we are given f of x equals x minus 6 squared plus 3. This is a quadratic function. And I know it is a quadratic because it's in vertex. It is in standard form. So it's in standard form. Right? So if you remember, standard form of a quadratic is in this form. Okay, now let's find the vertex. So this one's actually pretty simple to find the vertex because it is in standard form. There's no equation we have to do, so it's just the vertex. Some people could see it automatically. It's just the x value of this. So, or you could think of it as the horizontal shift. So it's actually 6, 3. Remember, the 3, if it's in standard form, the y value is always the k, and then the x value is this. Now, some people always get confused why this isn't -6. Remember, it's how you can remember is it's always the opposite of the x value, or what you can do is set the x minus 6, set that to 0, and then solve for x, right? And that's how you know your x value is positive 6, not -6. So we found the vertex. And this is we got to find, let's find, okay, so since this is let's find the x-intercept. But before I do that, I got to figure out, sometimes you may or may not have an x-intercept. So instead of trying to figure out what's your x-intercept by foiling, factoring, let's figure out if we even actually have one. So let's find, so what we're going to do is figure out if we actually do have an x-intercept. This only applies for quadratic. So this only applies, it's called the discriminant rule. Discriminant. So the discriminant rule is basically the b squared minus 4 times ac. And the rule states that if your outcome is positive, you're going to get 2 real solutions. If it's 0, you get 1. And then if you have a negative, you have 0. Okay, so this only applies, the discriminant rule only applies for quadratics, not polynomials. So it only applies to quadratic. So let's see how much, if we have an x-intercept, or if we do have it, how many x-intercepts do we have? So looking at this equation, let's see here. Before we figure out a or b, so let's up here, we have x minus 6 squared plus 3. We gotta FOIL it out, right? So when you FOIL x minus 6 squared, you're gonna get x squared should be a minus 12x plus 36, and then plus 3. So this is going to be x squared minus 12x plus 39, right? Okay, so let's find now what is my a? My a is 1. It's always the highest degree. It's always the coefficient of the highest degree. My b is negative 12, and my c is positive 39. So when you do b squared minus 4ac, you're going to get 12. B squared is 144 minus 4ac, so it's minus 4 times a, which is 1, and c is 39. So when you put it all together, you're going to get negative 12. So we have our outcome is negative, so that means we have zero x-intercept. So we don't actually have an x-intercept. Okay, so we have no x-intercepts. But there's no, okay, so if we have no x-intercept, could we have a y-intercept? We can. And if you recall, how to find the y-intercept is you just simply plug in 0 for x and then solve for y. So it's going to be y equals 0 minus 6 squared plus 3. And then this is going to be y equals 36 plus 3, which is 39. So my y-intercept is in coordinate form to be 0, 39. I always like to put it in coordinate form. So here's our y-intercept. We don't have an x-intercept. Is that enough to graph it? I think so. But before we actually graph, let's list all what we know. Let me put it right here. So what do we know about this graph? We have a vertex at 6,3. The book doesn't say axis of symmetry, but I'm going to write it anyway. We have an axis of symmetry, and that's at x equals 6. It's really simple to figure out the axis of symmetry. It's always the x value of the vertex, and make sure you always put it in equation form, like x equals 6. Otherwise, if you just put 6, it'd be wrong. And what else do we know? We have no x-intercepts. We have no x-intercept because we just did the discriminant rule and we have a negative, and the outcome was negative, so we have no x-intercepts. We have a y-intercept at what do we have? At 0, negative 12. What else do we know? Is this quadratic concave up or concave down? Since if A is positive, right? There's an invisible 1 right here. So we know it's not, there's no negative, and it's A is positive, so we know it's concave up. Concave up. And then, yeah, because since A is just 1. And what else do we know? I think that's it. Now we have enough information to graph it. So let's see here. Let's plot our vertex at 6, 3. Here's 6, here's 3. Here's my vertex at 6, 3. Our y-intercept is at 0, 39. So wait. Whoops, I made a mistake. The y-intercept is 0, 39, not. I don't know how I got 0, negative 12. So the y-intercept is 0, positive 39. Maybe I got that from a different problem. So here's 0, 39. And we know it has no x-intercept, so, and we know it's concave up, so just go ahead and connect these dots and try to make a U shape, just like this. So it should look something like this. And then the axis symmetry is at x equals 6. So if you recall, remember, you can graph x equals 6. It's a linear graph, but it goes completely horizontal. So, and since it's a symmetry, you're not going to put a straight line, you're actually going to put an asymptote. So x equals 6 looks something like this. This is my axis of symmetry. Okay, now what? I think that's it. We just graphed this quadratic function. It should look something like this. It should be concave up at vertex 6,3, y-intercept 0, 39, and then, yeah. That's how, that was number 1. Let's do number 2. So same directions, we got to sketch it, we got to find the vertex, x-intercept, and all of that good stuff. So let's see here. I'll kind of move it to the right so I have space. So we have this function f of x equals 1/4 x squared minus 2x minus 12. Notice that it's not in standard form or vertex form. So it's not a standard form. So we're going to have to do a little bit something different to find the vertex. If it's not a standard form, what you're going to do to find the x value of vertex is going to be, you're going to use this equation, x equals negative b over 2a. And then your y value is f of whatever that is. So whatever the x value is, you get that. Okay. So let's look at this. Since it's already FOILed out, we could figure out our a and b and our c. So my a is 1/4. My b is negative 2. And my c is negative 12, right? So let's find our x value for the vertex. So x is opposite of b over 2a, so it's going to be positive 2 times 2 times a, which is, what is a? What is a? 1/4. This simplifies as 2 over 1/2. Because 2 times 1/4 is 1/2. We have a complex fraction, so how you figure this out is you can either do the bracket way or just do 2 divided by 1/2, right? And then cross multiply. So that's 4. Or you can just do the bracket way. So here we have a denominator at 1, 2. So the common denominator would be 2. And then what you do is you times 2 by both the numerator and the denominator. So 2 times 2 is 4. And then 2 times 1/2 is 1. So you still get 4. So we found our x value for the vertex. Now let's find the y value. So the y value is whatever the x value is, you just put it inside the f function. So it's going to be f of 4 because 4 is our x value. You're going to get 1/4 times 4 squared minus 2 times 4 minus 12. You're going to get 4 minus 8 minus 12 equals negative 16. So our vertex, should I put it a little bit right? So our vertex is at, what is it? So it's going to be, vertex would be 4, negative 16, right? Our x value is 4, and our y value is negative 16. And then axis symmetry is simple, right? Axis of symmetry is at x equals 4 because it's always the x value of the vertex, and make sure you always put x as set it up as an equation. Okay, so let's find our x-intercepts. So before we do that, let me move this to the left so we have more space. Let's find our x-intercept, but before that, we got to use the discriminant rule to figure out if we have any, and if so, how many. So the discriminant rule is this thing, b squared minus 4ac. So what is my a? Is a is 1/4, b is -2, and c is -12. So b squared is going to be 4 minus 4 times ac, which is 1/4, times it by c, which is -12. So this is going to be 16. So if you recall, going back to the first equation, right here, if it's positive, you get two real solutions. So we get two x-intercepts. So let's see. We have two x-intercepts because our outcome is positive 16. Two x-intercepts. Okay, so now we got to figure out how do we find that x-intercept. So what you're going to do is find the x-intercept. You plug in 0 for y and then solve for x. So it's going to be 0 equals 1/4 x squared minus 2x minus 12. Now this looks kind of weird because of this 1/4. You should try. So I want to factor it, and then solve for x. But before that, make things a little bit more simpler. Let's get rid of that 1/4. We can get rid of that 1/4 if we multiply for both sides, right and left. So if you multiply for both sides, you're going to get 0 equals, and the 1/4 cancels. Wait. No, sorry, I take that back. Before we do that, I actually meant to mean, let's actually factor out that 1/4. That's what I meant. So we have 0 equals 1/4 x squared minus 2x minus 12. Let's factor it out. So this is going to be 1/4. This is going to be x squared. This is going to be now going to be -8x, because -8x times 1/4, you're going to get -2x. And then this is going to be -48. Right? Because -48 times 1/4 gives you -12. Set that to 0. Now I can get rid of that 1/4 by multiplying everything by 4, right? So the 1/4 times 4, they cancel, so you're left with x squared minus -8x minus 48. Now you can actually do simple factoring, because this does factor simply. I'm going to do x and x, and then I'm going to use +4 and -12, because 4 times -12 is -48, and then 4 plus -12 gives you -8. Now we got to find the 0, so you can set that. Some people already know it, it's just x equals -4 and +12. But if you forgot, what you can do is set these two parts. We have an x plus 4, set it into equation and set this to 0, right? So x plus 4, this is x plus 4 equals 0. And then I want other equation, x minus 12 equals 0. And then to solve from that, x equals -4. Excuse me for one sec. Okay. Sorry. back. Okay, so now over here we got to solve for x, so I'm going to add 12, add 12. So I get x equals 12. Okay, so now we just found our x-intercept, and sometimes you got to put it in, I always like to put it in coordinate form, right? So my x-intercept in coordinate form would be, now this is my x value, so it's going to be actually -4, 0, and then our other x-intercept is at 12, so it's going to be 12, 0. I just like to put it in coordinate form because when I graph it, it makes it so much easier. So here's my x-intercept. Okay. Now that we found our x-intercept, what else do we need? Okay, so is this graph concave up or concave down? Since there's no negative in front of the 1/4, we can conclude that this is concave up. And is that enough to graph our quadratic? I think so. Yes, we can graph it now. So let's go back to the graph. So my two x-intercepts at 12, 0. So my first one is 12, 0. And my other one is at -4, 0. So right here. Oh, we got to find another point, and that's going to be our Y-intercept. So I think it's simple. To find the Y-intercept, you plug in 0 for the function. So this is going to be 0, because 0 times, you're plugging in 0 for x, so 0 times 1/4 is 0. This is going to be 0. And then you're just left with -12. So my Y-intercept in coordinate form is at 0, -12. So let's pretend that this graph is not up in scale. So this is -12 right here. Okay. And then you just connect the dots. Oh wait, let's plot. So okay, here's my x-intercept 12, 0. My other one's at -4, 0. My y-intercept is at 0, -12. So let me write this down. This is -4, 0. 12, 0. This one is at 0, -12. And then what else can we find? The vertex. What was our vertex? A vertex is 4, -16. So 1, 2, 3, 4. Yeah, this graph is not in scale. So here's -16. So this point is at 4, -16. And then make sure it's concave. Now you connect the dots and make sure you're concave up. So it will look something like this. Yeah, my graphs are never the best. Make sure it should look something like this. And then remember we have to do the axis symmetry. So the axis symmetry is that x equals 4. So here's 4. And then you just make that vertical line x, right? It goes straight like this. Here's our axis symmetry. So x equals 4. Okay. And that's how you graph this function f of x equals 1/4 x minus 2x minus 12. Okay. Okay, so now let's go to number 3. Now we're kind of going, now this one's a little going backwards. It says, number 3 says, find the standard form of the quadratic function. Find the standard form of the quadratic function. So they give us a graph of this quadratic function. We got to find the equation of this. So it's kind of like going backwards. Okay, so we got to find an equation for this quadratic, but look, they give us 3 points. An x-intercept at 1, 0, another x-intercept at -3, 0, and then a vertex at -1, 4. So let me write that down. So we have 3 points. 2 of them are x-intercepts. So at x-intercept is at 1, 0, right, over here. And then our other one is at -3, 0, right here. Now, we have a vertex at where? -1, 4. And then, yeah, so now we got to solve an equation. Since they give us an x-intercept, I'm going to use this equation. Y equals A, and then it's going to be x minus our x-intercept. So it's going to be, one of them was 1, so it's going to be x minus 1. And then it's going to be x minus our other x-intercept. So it's -3. So it's going to be a minus and -3. And we know that 2 minuses comes a positive. So it's just x plus 3. So let me simplify this. This is going to be a times x minus 1. And then this is going to be x plus 3. Okay, now what do we got to find, in order to find the equation, we got to find a. So this is what we want to find. So in order to find a, we got to plug in points. We can't use any more of these points because we use these points all up. We use it all up. Let's use this point, our vertex point, the -1, 4. So this -1 is my x, and this 4 is my y. So we're just going to put those numbers into this equation. So we said that y is 4. We don't know what a is. That's what we want, so we'll just leave that as a. And then we said that our x value is -1, because this is our new x value. So it's going to be -1, -1, and then it's going to be -1 plus 3. Let me simplify this. -1 minus 1 is -2. And then -1 plus 3 is +2. Okay. Almost there. So -2 times +2 is -4, and then you have an a, so it's -4a equals 4. Let me solve. I want to solve for a, so what I'm going to do is divide -4 from both sides. So a equals -1. So we found our a. So that's all we really need. So it's going to be y equals a, which is -1, times it by this equation right here. Sorry, this one. It's going to be x minus 1, and then x plus 3. Now, they want it in, the direction says to put it in standard form. This is not standard form. I gotta do some adjusting. I gotta FOIL this out first. So let me FOIL this out. So this is gonna be -1. When you FOIL this out like that, you're gonna get x squared plus 3x minus 3. So this is x squared plus 2x minus 3, minus 3. And then times this by -1. So you're going to get y equals -x squared minus 2x plus 3, right? Now, the direction says put it in standard form. This is not in standard form. In standard form, it looks something like this: y equals ax minus h squared plus k. So we have to make this look like this. So what we have to do is called completing the square. We got to complete the square. Complete the square. So we can make it look like this. So what I would do is, first I would do is factor out that negative. So it's going to be y equals -1. And then this is going to be x squared plus 2x minus 3. Then what I would do is do you see this -3? I want to move it to the right. So what I'm going to do is I'm going to add 3 to both sides. So I'm going to move this 3 and I'm going to add it to the, actually moving this 3 to the right. So that could be my k value. So this is going to be y equals negative, that negative doesn't go away, so it's just x squared plus 2x. And then we don't know, remember this 3 to the right? We don't know that term. And then it's just plus 3, right? To find this term, you take half of b. So remember our b is 2. You take half of b, so 2 over 2 is 1. And then you have to square that number. So 1 squared is just 1, right? And then you have to add 1 to the k on the right side. So you're going to add 1 right here. So this is going to be negative x squared plus 2x plus 1. And then there's a plus 4 right here. But we got to put it, we kind of have to put it backwards. When you factor this out, or when you FOIL it out, this is going to be x plus 1 square plus 4. So this is your final equation. Now you're probably thinking, how did I get that how did I get x plus 1? It's actually one of your factoring rules. I'll show you. Yeah, it's actually called the perfect square trinomial. So let me write it. Perfect square trinomial. So the perfect square trinomial looks something like this. It's a squared plus 2ab plus b squared, and that should equal a plus b squared. So let's go back to this equation. So our so this right here, x squared plus 2x plus 1, looks something like this. We just got to make it look to the right, because now we have to make it look to the right. So we got to figure out our a and our b. So my a is going to be x, because when you square that, you're going to get x squared, right? And my b is going to be 1, because it's plus b squared, and then we know that if you do 1 square, will give us 1, so that's how you get x squared plus 2x plus 1. So that now we just got to put it in this form, a plus b squared. So it's just x plus 1 squared, and then plus k, which is 4. Okay. Okay, let's move on. Okay, so number 4 says find the quadratic function that has the indicated vertex and whose graph passes through the given point. So let's see. They give us the vertex at, it says vertex at 5, 12, and then a point at 7, 15. And we said the direction says find the quadratic function. So we have to make an equation for this quadratic, and we got to it's just like 3, but it's a different form, right? They give us a point, a vertex, and a point. But this time we're going to use what's called standard form. The reason why we're going to use standard form is because they don't give us 2 x-intercepts. So this is the same process, just like 3. We got to make an equation, got to find a and stuff. But we're going to use standard form because they give us a vertex and a point, not like the last one where they give us two x-intercepts and a vertex. So yeah, if they give us a vertex and 1 point, we're going to just make sure you use the standard form. So if you call standard form as x minus h squared plus k, and then it's going to be y. Let's plug in what we know. So y, we don't know what a is, so it's just a. And then our vertex, remember, it's going to be actually, since our vertex, this is like the form of the vertex, right? So what would that be? So we would set up as x minus 5 square, because when remember our vertex is at positive 5. If you set x minus 5 and you set that to 0, you're going to get 5, 5. So that's x equals 5. So that's why we're going to use x minus 5, not plus 5. And then our k is just whatever the y value of the vertex is. So it's just plus 12. There's no, for the k, there's no manipulation. It is what it is. And then let's see, what else do we know? Let's find our a. Our goals, let's find our a. So we don't know what a is. Now, what are we going to plug in for x? We're actually going to use a new point. We're going to use this point right here, 7, 15. And then 7 is our x, and then our 15 is my y. So plug it in. So it's going to be x is 7 minus 5 square plus 12. And then what it was our y was? Our y is 15. So it's going to be 15 equals a. And then 7 minus 5 is 2. So that's going to be 2. Square that plus 12. Okay, we're almost there. 2 squared is 4. So it's 4 times a. And then plus 12 equals 15. Let's solve for a. So what I'm going to do is subtract 12. So this cancels. So 15 minus 12 is 3. That's 4a. Divided by 4. Divided by 4. You're going to get a equals 3/4. Okay. Now we found our a. Let's put it. So our final equation is going to be y equals a, which is 3/4. And then it's going to be x minus 5 squared plus 12. So this is your final equation for this quadratic function when given this vertex point and this point. Okay, let's move on. Let's go to number 5. Number 5 says find two quadratic functions find two quadratic functions, one that opens upwards and one that opens downwards, whose graphs has given the x-intercepts. So we're given this two x-intercepts at -3, 0 and -1/2, 0. So we need two equations, one that opens up and one that opens out downwards. So let's do the open up one. Let's start with the one that opens up. So it's just like kind of like number 3 and 4. So since they give us two x-intercepts, we're going to use this equation. A equals x plus 3, and then x plus 1/2. Yeah, it's just like number 3. So the reason why it's plus 3, because remember it's -3. So the opposite of that would be positive 3, and then our other x-intercept is -1, so the opposite of that is 1/2. So if you solve these, if you put these, set those to 0, you're still going to get -1/2 and then -3. That's how I got 3 and positive 3 and positive 1/2. And let's FOIL it out. Wait a minute. Our a, did they give us an a? Oh, if this is opens upwards, what are we going to call a? It's going to be positive, right? Or we could think of it as a positive 1, because there's always an invisible 1 if it's just by itself. So we'll just replace a with 1, and then it's going to be x plus 3 times x plus 1/2. Okay, FOIL this out. You're going to get x squared plus 1/2 x plus 3x plus 3/2. So your equation is going to be f of x equals x squared. 1/2 plus 3x is positive 7/2 x. And then just positive 3/2. So this one over here opens upwards. Now we got to find the one that opens downwards, and that we can use the same equation, but instead of positive 1, we can use -1, because now we want something that opens down. So let's do opens down. So it's going to be y equals, instead of positive 1, we're going to use -1. And then we're going to use the same equation, x plus 3, x plus 1/2. So this is going to be, when you follow this out, remember it's still the same thing, x squared plus 7/2 x plus 3/2. Now we got to distribute that negative, so it's going to be y equals negative x squared minus 7/2 x minus 3/2. So this equation is the one that opens downwards, opens down. Okay, so those are your two equations for number 5. Okay, number 6, this is a word problem. So let's see. Okay, so number 6 says, it says the height of y in a feet, the height of y in a feet of a ball is thrown by a child, and they give us this equation, y equals -1/2, -112 x squared plus 2x plus 4, where x is the horizontal distance in feet from the point at which the ball is thrown. So we got to find 3 things. How high is the ball when it leaves the child's hand? What is the maximum height of a ball? And how far does the ball strike the ground? So when you're looking at this equation, they give us a diagram. This, if you were to look at this closely, what is this? This reminds you of? This reminds you of a quadratic function, right? But it's open. This quadratic function opens downward. So let's keep in mind when we're doing these problems. So think of quadratics when we're doing these problems. Quadratic, and it's it opens downward. So let's first find A. So wait, first let me rewrite the quadratic function, because this is a quadratic function, -1/12 x squared plus 2x plus 4. So it says, how high is the ball when it leaves the child's hand? So here, when it leaves the child's hand, you could think of it as physics. So what would be, think of it, if it's right here, what is the time? It would be, or what would be the x value? Or the time, it would be 0. So what you're going to do is plug in 0 for this function, or you can think of it as finding the y-intercept, right? You could think of it as finding the y-intercept. So how do you find the y-intercept? You plug in 0 for the function and then solve for y. So this is going to be y equals -112 times 0 is still 0. 2 times 0 is 0. And then you're just left with 4. So you get a y value of 4. So that y value, or 4 feet, is how high is the ball, is how high. 4 feet is how high the ball when it leaves the child's hand. So this is part A. So the answer is just 4 feet. Okay. Yeah. Think of it for part A, just think of it as the y-intercept. Or when in physics, you could think of it as when time is 0, if that makes sense. Number B, or question part B, says, what is the maximum height of the ball? So remember, think of quadratic. And this is a concave down quadratic function. So it looks something like this, right? It's a concave down. Here's my x and here's my y. The question says, what is the maximum height of the ball? So the maximum height of the ball would be around here, right? What is this point called? I mean, or actually, excuse me, it should look, that's also the y-intercept, but let me put it right here. I don't want you to get confused. It should look something like this. It's concave down. Yeah, there we go. This is a quadratic and it opens downwards or concave down. And they want to know what is the highest point of this? What is the maximum height of the ball? So they're probably thinking, what is this point right here? What is this point in quadratic form? This is also called the vertex, right? If you recall, this is the vertex. Now we got to find actually not the x value of the vertex. We got actually, because they're asking what is the maximum height. So this is the height, right? So what do we got to find of the vertex? We actually got to find the y value. We got to find the y value of the vertex, right? So that'll give us the highest maximum height of the ball. So let's find the y value of the vertex. We know how to find the vertex. Let's see here. So we have this function. Since it's not in standard form, right? We got to use, to find the x value, you got to use this equation x equals opposite b over 2a, and then whatever that value is, then we can find the y values. So my a is what? -1/12. My b is 2, and my c is 4. So opposite of b is -2, and then 2 times a is -1/12. This becomes -2 over 2 times -1/12 is -1/6. 2 negatives becomes a positive, right? This is a compound fractions, or you could do 2 divided by 1/6, and then from there cross multiply. So 6 times 2 is 12, and then 1 times 1 is 1. Or you could do the bracket way. This has a 1 here, this one has a 6, so my DCF is 6. And then what you do is do 6 times 2, which is 12, and then 6 times 1, 6, it's just 1. So either way is correct, you'll get the same answer. So this is just the x value of the vertex. Remember, we got to find the height, so we got to find the y value. So we're not done yet. So what we have to do is, to find the y value, simply have to do is plug in the x value into this function. So we're going to do y of 12. So when you plug in that, that's going to be -1/12 times 12 squared plus 2 times 12 plus 4. So this is going to be 12 squared is 144, divided by 12 is just 12, but there's a negative, so it's -12. And then 2 times 12 is 24, plus 4, the outcome is just 16. So our height of the, or part B says, our height is, what is the maximum height of the ball? So our height is 16 feet. Well, it's just the y value of the vertex, so it's just 16 feet. Right? So here's a vertex at 12,16, and this is what we want to know, the height. Okay, so that was B. Now let's do part C. It says how far from the child does the ball strike the ground? How far? So what they're thinking, so what they're asking is, see the x? Let's go back to this graph. They just want to find the x-intercept. That's what C is asking you. We got to find the x-intercept of this quadratic function. That's what they're asking. It says, how far from the child does the ball strike the ground? They're asking, what is the x-intercept? Right? Because this is the x-intercept. Okay, so let's do C. So how to find the x-intercept? So we're given this equation, y equals negative 1/2 12 x squared plus 2x plus 4, right? To find the x-intercept, you plug in 0 for y and solve for x, right? Okay, now I don't want to do the quadratic formula. Actually, we're gonna have to do the quadratic formula because this will not factor out well. Even if you took out that 112, it wouldn't factor it out. So let's see here. We're gonna use remember the quadratic x equals opposite b plus or minus root b squared minus 4ac all over 2a. So let's see here. Where's my a? Our a is negative 112. Wait, actually, before I do that, let me factor the 112 first, then we can go from there because they won't factor. So when you take out 112, you're going to get x squared minus 24x minus 48 equals 0. And then if you multiply everything by negative 112, you get 0 equals x squared minus 24x minus 48. This does not factor. That's why we have to use the quadratic formula. But since this is easier, we're going to use a equals 1, b equals negative 24, c equals negative 48. You could also use a as negative, or you could also use a as negative 112, b is 2, 4, but I don't want to deal with fractions. This might be simpler. So our x value is opposite b, so it's 24 plus minus, and then I'll just do this. If you have a calculator, I'll just do it. I'll just give you the answer. B squared is 576 minus 4 times 1, because a is 1, and our c is negative 48, all over 2a, which is just 1. So you're going to get two x values. X equals 24 plus square root of 768. If you do the math, you get 768 over 2. And then remember that we have two answers and negatives, so it's going to be x equals 24 minus square root 768 over 2. We're going to get, for this part, we're going to get negative 1.856, and then over here, we're going to get 25.856 feet. Okay, we have two answers. We can't use the negative, right? We can't use the negative because our distance cannot be negative. There's just no way our distance could be negative, right? So we're going to only use the positive x value. So it's going to be 25.x, this one. But I'm going to round it to 2 places. So our x value is going to, or our distance, this is our distance, is at x equals 25.86 feet. This is your final answer for part C. Okay. That was 6. Let's do 7. And exercise 7 through 8, find all the real zeros of the polynomial. Determine the multiplicity of each 0. Okay. So now we're dealing with polynomials. We're not doing quadratics anymore. we're dealing with polynomials, and then they say we got to find the real zeros. So when they say real zeros, they automatically mean find the x-intercepts. Okay, so when they say real zeros, find the x-intercept, and then we got to determine the multiplicity of each zero. So this is really important when graphing a polynomial, because the multiplicity determines if it crosses or bounces the x-axis. So first, let's find our zero. So let's find our x-intercepts. We gotta there's so many. We gotta factor this out to find our x-intercepts. And I'm looking at it, and there's one thing we can take out. We can take out a 1/3, right? So this is 1/3 x squared plus x, and this is -2. Because 1/3 times x squared is 1/3 x squared, and when 1/3 times x is 1/3 x, and 1/3 times -2 is -2/3. Good. This equals f of x. So now this actually simplifies as the 1/3 just stays the same. So this actually simplifies as x, and then I'm going to use +2 and then -1, because we need two numbers when multiplied gives you -2, and when added gives you +1. So that's why I'm using +2 and -1. So this is our equation. This is the equation. There's one more step. We got to find our zeros. So let's find our zeros. So how to find the zeros? Some people know that our zeros is at -2 and 1, right? Some people could say, oh, that's by looking at this. Our zeros or our x-intercept is at -2, and our other one would be (1). But some people don't know. So what you have to do is how to find the zeros. You set y to 0. So our f of x is 0. And then 1/3 x plus 2 times x minus 1. Our goal is to solve for x, so what I could do is get rid of this 1/3 and multiply everything by 3, so this is 0. This is x plus 2, x minus 1. Then solve for x. So you could break it into two parts as x plus 2 equals 0, and then x minus 1 equals 0, and solve for x. So that's how we get -2, and then our other one is at +1. So our zeros is one of them is at -2. Now, where we got that -2, we got it from here, from this equation. Notice that this is not square, or this has an invisible 1 because it's by itself. So that 1 degree means it's odd, so it has a multiplicity of 1. So I'll say at x equals -2, it has a multiplicity of 1, because we got an x value. We got it from this equation, and then we know this has an invisible 1. What is our other x value? 1, +1, right? So our other x value is at x equals 1, and then this one has a multiplicity of 1 as well. So remember, where did we get x equals 1? We got it from this equation, and we know that this has an invisible 1 because it's by itself. So that means it has a multiplicity of 1. So this is actually your answer. It's just this thing. Our zeros at -2 has a multiplicity of 1, and our other zeros at x equals 1 with a multiplicity of 1. Yeah, that's all they're asking. They don't ask you to graph it. But I just want to make sure when you do graph it, when you plot the point -2, 0, right? This is not part of the answer. I'm just going to tell you ahead of time. So when you plot these x-intercept -2, 0, and then 1, 0, notice that 1 has a multiplicity of 1. It's odd. It's not even. So when you have an odd multiplicity, it actually crosses the x-axis. So I will go over that on, I think, the next few problems when we graph. I think it's the last one that where you have to graph a polynomial. For this one, they just want to find the zeros and the multiplicity. The same thing with number 8. We got to find the zeros and multiplicity. So how to find the zeros is they're actually finding the x-intercept. So we gotta factor this somehow. Now there's so many techniques of factoring, but I noticed there's something special about this one. There's how many terms are there? 1, 2, 3, 4. There's a total of 4 terms. So when I know there's 4 terms, I can actually automatically try grouping by factoring. Grouping by factoring. This only works if you have 4 terms. If you don't, you're going to have to do another style of factoring. So first, to do grouping factoring, you break it into two parts. I'll break it to this part, x cubed plus 3x squared, and then the other part, negative 4x minus 12. So let's focus on the x cubed plus 3x squared first. So x cubed plus 3x squared, when I factor this, is there anything we can take out? You can. What can you take out? You can factor out an x squared. So this is going to be x squared, and then this is going to be x, and this is going to be plus 3. Good. Now let's look at this part, the second part, negative 4x minus 12. Is there anything you can take out? Yes, you can. And you can take out a negative 4. So this is going to be negative 4 times x plus 3, right? Because negative 4 times x is negative 4x. Negative 4 times positive 3 is negative 12. Good. We're almost there. Should equal g of x. And then notice, is there anything that repeats the same? Yes, the x plus 3. When you have something that repeats the same, that means grouping by factoring actually works. So yes, that's a good thing. So now our new equation, whatever that repeats more than once, you just have to write it once. So the x plus 3, just write that once. And then you bring down whatever your leftover is. So we are left over with an x squared and a minus 4. So this is going to be x squared minus 4 equals g of x. We're almost done. Now we have this factor form. Can this be broken down even more? Yes, it can. The x squared minus 4 can, and it's a perfect square, right? It's a perfect square, so when you factor x squared minus 4, you're going to actually get x plus 2, and then x minus 2. And then don't forget the x plus 3 equals g of x. And then our x values, our x zeros are 2, negative 2, and positive 3. And if you do get confused how I got 2, negative 2, and negative 3, you can break it into 3 parts. X plus 2 equals 0, x minus 2 equals 0, and then x plus 3 equals 0. And then solve for x. So that's how I get negative 2, positive 2, and x equals negative 3. Good. So here my zeros are, this is the answer. One of my zeros is at x equals 2. So where did we get 2? We got it from this part, x minus 2, right? And notice that it's by itself. So when it's by itself, it has an invisible 1. So at x equals 2, it has a multiplicity of 1. Okay. Now, what about our x negative 2? We got that x negative 2 from this equation. Notice that it's by itself, so it has an invisible 1. So it has a multiplicity of 1 as well. And then our other one is that x equals negative 3. we got -3 from this equation, right? X plus 3. This 2 has a multiplicity of 1 because it's by itself. Multiplicity of 1. Okay. So that's your action. That's all they're asking: the zeros and the multiplicity. Okay. So if it has an odd multiplicity, that means it's going to crosses, and if it's even multiplicity, it will bounces. I will go over that on the last problem. Number 9 and 10. Let me zoom out. In exercise 9 through 10, find the polynomial that has the given zeros. So we got to find the equation of this polynomial. So let's do 9 first. On number 9, we have 2 and -6. So these are our zeros. Now we just got to find out the equation of this. So our equation is going to look something like this. So since 2 is positive, our equation is going to be x minus 2, right? Because when you actually solve for x, you get positive 2, right? That's why it's x minus 2, not plus 2. And then this is going to be x plus 6, right? Because when you solve for x, you get a -6. You could leave it like this, or you could do one more step, FOIL it out. So when you FOIL this out, you're going to get x squared plus 6x minus 2x minus 12. And then it simplifies as f of x equals x squared plus 4x minus 12. Okay, so this is answer number 9. Now, number 10 is a little bit trickier because we're dealing with conjugate theorem. We're dealing with the conjugates. So notice that these two are conjugates. So when you have a conjugate, you're going to use the conjugate theorem, conjugate pair theorem. Hold on, let me find it. Yes. So we're going to use the conjugate pair theorem because these are conjugates. Keep saying that. Conjugate pair theorem. And yeah, and you only use this when you have a conjugate. So when you're going to set it up a little bit different. So it's going to be, when you have the conjugate, you're going to do x. This is how you set it up. Don't ask me how or why it's like this. This is just how you set it up. It's going to be x. I'm going to use bracket x minus, then I'm going to use the first one, which is 1 plus square root of 3, minus, and then minus parentheses 1 plus square root of 3, parentheses, bracket. And then I'm going to use a bracket, and then it's going to be x minus the other conjugate, the other pair, which is 1 minus square root of 3, parentheses, bracket. Now, before you go crazy and FOIL and factor, let's actually distribute, let's simplify this. For this one, let's distribute that negative. So it's going to be x minus 1 minus square root of 3, bracket. And then when you FOIL this out, this is going to be x minus 1 plus radical 3, bracket. Now, before you actually simplify, look at it very closely. Does this look like any of one of our factoring rules? It is, it does. It looks almost like the perfect square, right? The perfect square. Perfect square, remember it's a plus b, a minus b equals a squared minus b squared. So it looks like, oh, it looks exactly like this part, this left side. So we got to make it look like the right side. So let's figure out our a. My a is just x minus 1. And my b is just radical 3, not negative. It's just the radical, so it's just root 3. So we'll put it, we got to put it in this side, a squared minus b squared. So it's going to be x minus 1, because our a is x minus 1, square minus b square, and so that's radical 3 square. When you FOIL this out, x minus 1 square, it's going to be x squared minus 2x plus 1. And then it's a minus radical 3 squares. So remember, when you take the radical, when you square a radical, what happens? The radical disappears, so it's just 3. So your final equation is going to be, when you simplify this, this is going to be x squared minus 2x, and then 1 plus negative 3 is negative 2. Okay. So yeah, this one was a little bit different because we had to use the conjugate pair theorem. This also applies, this also applies to imaginary numbers. So let's say you had one plus I, and then the other conjugate was 1 minus I. You're going to use the same process as this one because there are conjugates of each other. So yeah, you're going to use the same exact setup for this equation because they are conjugate, and remember I square is negative 1. Okay. So that was that one. Let's do number 11. 11 says, find the polynomial of a degree n that has the given zeros. Zeros at x equals -5, positive 1, positive 2, and the degree of n equals 4. Now, there's so many correct answers for this one. So if one, there's just so many, there's more than one correct answer for this one. So we got to figure out the polynomial of this equation. So x is going to be, f of x equals going to be, since one of our x values is -5, I'm going to use x is plus 5, because when you solve that to 0, set this to 0 and solve for x, you get -5. That's why I'm using positive 5. And then I'm going to use x minus 1, and then x minus 2. So I hope you guys understand that, why I'm using -1 and -2 instead of positive 1 minus positive 2, because it's just, think of it as the opposite of 1 and opposite of the negative sign, the negative of 1, the negative 2. Because if you were to set this to 0, you get positive 2, and this gives us positive 1, if that makes sense. Since we need a degree of 4, this has alone, if it's by itself, it has a divisible 1, 2, 3. If you FOIL this out, we only get an x cubed, but we want a 4, so one of them has to be a 2. And I'll set this as 2, but you can do whatever you want. You could put this as 2, this could be 1, and this could be 1, as long as they all add up to 4, right? So you could leave it like this. I did one step further. I actually FOILed it out. So when I FOIL this out, this is going to be x squared plus 2x plus 25. And then when you FOIL this to x minus 1 and x minus 2, you're going to get, x squared minus 3x plus 2, right? And then when you FOIL all this out, you're going to get this, x fourth minus 3x cubed plus 2x squared plus 2x cubed minus 6x to the square plus 4x plus 25x squared minus 75x plus 50. And then if you finally simplify, this is what you're going to get. X to the fourth minus x to the cubed plus 21x squared minus 71x plus 50. So this is your polynomial equation for this when they give you these zeros and this degree. Okay. Yeah, and yeah, you can have more. There's more than one correct answers. Okay, number 12. Oh, this is our last one. Yay. Okay, so this is all about graphing polynomials, and I'm going to teach you how you graph a polynomial. So it says sketch the graph of the function by A, applying the leading coefficient test, or you could think of it as the end behavior, if you guys remember, if you guys are learning that. B, find the zeros of the polynomials. We just went over the zeros, right? And then C, plotting sufficient solution points. And D, drawing the continuous curve through the point. So they're just asking, they want you to graph this polynomials, find everything about, yeah. So they're asking, you gotta graph this polynomial. So part A is really asking, when they say applying the leading coefficient test, they're asking pretty much the end behavior. So to find the end behavior, you kind of have to FOIL this out, but not completely. You just got to find the highest degree. So when you do t minus 2 square, when you FOIL it out, what's your first term? It's going to be t squared, right? That's all we want, because we just want the highest degree. The same thing with here. When you do t plus 2 square, what is your first outcome? It's going to be t squared, right? We don't care about the rest. We only care about the highest degree. And then don't forget about this negative, the a. So that's negative 1/4. So you're going to get, I'll call that y. This is going to be negative 1/4 t. Now, when you multiply two powers, you're really adding powers. So 2 plus 2 is 4, so it's going to be t to the 4th. Do you know how to graph y equals negative 1/4 t to the 4th? I think you do. Since this, okay, so let's graph negative. Well, let's roughly estimate it. We don't need to go we don't need to make it fancy. We just need a rough estimate of negative 1/4 t to the 4th. We know that 4 is an even, so it looks something like this. It's a little bit wider than the square, x squared. So this is what a typical y t to the 4th power. Now this negative 1/4 actually just means there's a reflection on the x-axis. So it's flipped. So it looks something like this, roughly. Now this is really important when you graph the graph, because this is what's called our end behavior. Okay, this is our end behavior. So that was part A. Now part B says find the zeros of the polynomial. So we got to find, when they automatically say find the zeros, you automatically think find the x-intercept. So let's find the zeros or the x-intercept. So to find the x-intercept, you plug in 0 for y and then solve for x, or in our case t. So it's going to be 0 equals negative 1/4 t minus 2 square t plus 2 square. Okay, now let's see here. To make life easier, I want to get rid of this negative 1/4 because I don't really need it. So what I'm going to do is multiply both sides by negative 4, right? That'll get rid of the negative 1/4. Make sure you do it on the left side as well. So 0 times 4, negative 4 is still 0. That's going to be, and then this is the negative 1/4 that cancels. Negative 1/4 times negative 4 cancels. So you're just left with t minus 2 square, and then t plus 2 square. Okay, now we have like two parts. Some people are going to automatically figure out, oh, our x-intercept is 2 and negative 2. But if you don't know, you could break it into two parts, because there is I see two equations. We have a t minus 2 square, and then set that to 0. And then our other equation is at t plus 2 square, and then you set that to 0. When you solve for this one, when you take the radical, when you solve for t, you're going to get t equals 2, right? Because you're going to get t minus 2 equals 0, and then you add 2 until we get 2, positive 2. And over here, what is our t value. So when you take the radical, you get t plus 2 equals 0, minus 2, minus 2. We technically have four x-intercepts, but since, okay, so remember now this is where we talk about multiplicity. At t equals 2, what is our multiplicity? Our multiplicity is at 2 because we got it from here. It has a degree of 2, so it has a multiplicity of 2. That means it's an even multiplicity. So that means it bounces the x-intercept. So I'll show you what I mean by bounces and crosses. At negative 2, what is this multiplicity? Multiplicity at 2, right? Because we got negative 2 from here, so and it has a degree of 2. So it has a 2, so that means it's even, so it crosses the x-intercept. Okay, that was part B. We found the zeros. Now we got to find sufficient solution points. So we already know the x-intercept, but what other point don't we know, which we could easily find? We could also find the y-intercept, right? How do you find the y-intercept? You plug in 0 for x, or in our case, 0 for t. So this is going to be y equals negative 1/4, and then it's t minus 2, so plug in 0 for t, so it's going to be minus 2 square, and then it's t plus 2, so plug in 0 for t, so it's 0 plus 2, so that's just 2 square. So you're going to get, when you negative 2 squared is positive 4, and then 2 squared is positive 4 as well, and times it by negative 1/4. 16 times negative 1/4, you're going to get negative 4. Okay, so we just found another point, which is our y-intercept at, and I always put it in coordinate form, 0, negative 4. Okay. Okay, so now let's graph it. Let me put it right here. Whoops. Zoom in a little. I hope you can see this. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So here's 2, 4, 6. Negative 2, negative 4. This is negative 4. So this is x and this is my y. Okay, so let's plot our y. Let's plot up what points do we have. We have a y-intercept at 0, negative 4. Plot that one. 0, negative 4. We have two x-intercepts. Well, actually, we have 4, but the degrees of what determines if it crosses or bounces. So at our first one is at 2, positive 2. So that would be 2, 0. And our other one is at t negative 2, so that's going to be negative 2. Before we go any further, let's plot our end behavior. So remember, this is our end behavior right here. So it's like, it goes concave down, so it's going to look something, we could go out, so our end behavior, it's going to look something like this. It goes downwards. Okay. Now let's determine it using our multiplicity if it crosses or bounces the x-axis. So at negative 2, it has a multiplicity of 2. So that means it bounces the x-axis. So here's our x-axis. What it means when I say bounce, it just curves like this, or bounce, and goes down to negative 4. And then at positive 2, it has a multiplicity of 2. Since it's even, so that we know if it's even, it bounces as well. So it makes that curve like this. It bounces or makes a curve. and then goes down to 0, -4. Okay, so that's how you graph this polynomial. You find your x-intercepts and your y-intercepts, determine the multiplicity. So one of our multiplicity was at -2. Since it's even, it bounces. So it bounces looks like it makes a U shape. If it's odd, it crosses. So what I mean by cross, it would go something like this. It would actually cross the x-axis like that. But ours doesn't. So it makes a U shape because it bounces. Okay. Okay, that is part 1 of chapter 3 exam, practice exam. So there's gonna be more parts later on. So just stay tuned. And that wraps it up for today.